So the last section we had in 7.3, we were able to either add down to see things eliminate, or we were able to subtract down and see what would happen. However, that's not always going to work. And so in section 4, what we have to do is we're going to have to multiply first. So we want to choose a variable to eliminate. In this case, I'm going to choose to eliminate x. And in order to do that, I want to have numbers that will either add to equal 0 or be the same, and I can subtract. I myself like to make them add to equal 0. So if I have a positive 2 on top, I'm going to multiply the second one by a negative 2. So I'm going to multiply every term by negative 2, including the constant at the end. And when we take this the way it was and add them, we're going to find out that the x's eliminate as planned. So here's what we would have. We would have no x's left. Negative 1y equals negative 4, which means y equals 4. From there, we're going to take that answer and we're going to plug it back in so I can find out what x actually is. So x plus 2 times 4 equals 5. Which means x plus 8 equals 5. And x is, in fact, a negative 3. So my final answer in this particular problem is negative 3, 4. Okay, that's our final answer. So sometimes you only have to multiply one equation. In this particular problem, I think either equation is a good idea as far as what we're going to work with. I could easily add down by multiplying the top equation by a 2. If I really wanted to subtract, I would probably just multiply the bottom equation by a 3. So, as before, I myself prefer to add because we tend not to subtract correctly. So this time I'm going to take the top equation times a positive 2, which will get me a 6a minus 2b equals 2. And I'm going to take the bottom equation just the way that it is. And we can add down. So I have 7a, 0 of those equals 7, and a equals 1. Now that I know what a is, I'm going to take that answer, I'm going to plug it back in so I can find b. So it doesn't matter which equation we use, we just have to make sure it works. We can always double check it. So I'm going to subtract 1 from both sides and divide by 2. 4 divided by 2 is 2. My alphabetical solution is 1, 2. And it should make both solutions true. So if I said 3 times 1 is 3, 3 minus 2 is 1, that works. And we just use this equation to get it, so that works as well. So our final answer here is 1, 2. Keeping in mind, if we really wanted to, we could have solved this a different way, right? So I could have said I want to take everything times 3 and subtract. Now this particular problem is a little bit different because I'm not going to be able to do this with one multiplication. In this case, I will be multiplying both equations. So I'm going to choose to add. So in my case, I'm choosing to eliminate y, which means I'm going to take this top equation times a 7, 28x plus 35y equals 42. And take this bottom equation times a 5 because I'm trying to get a common number here. So that's going to be a 30x minus 35y equals negative 100. So we always have to be careful about negatives no matter what. In this case, that adds me 58x. That's 0y is equal to a negative 58. So while these numbers are really nice, they don't always have to be. So we have x equals 1, and we're going to go back and plug that in to find the y value. I'm going to choose to plug it into the top equation this time. So I'm going to have 4 times negative 1 plus 5 times y equals 6. So if I multiply that, I'm going to end up adding it over. So I have 5y is equal to 10, and y is equal to 2. My ordered pair solution being negative 1, 2. Your answers can be fractions, they can be decimals. You may choose to subtract down. And again, if you do that, make sure, if you were to subtract down on this problem, that we would multiply the top equation by nothing. The second equation would get multiplied by a 3, so that would be a 3a plus 6b equals 15. And you have to make sure you subtract everything. So I would end up with 1 minus 6 negative 5b equals 1 minus 15. Yep. Which is a negative 4b. That was positive. So it doesn't necessarily always work out as it should. It should be that this is going to be a different number. But you'd have to make sure you subtract all the way across. I'll find my mistake eventually. But this section, you have to multiply 1, decide on a variable, multiply one or both equations, and continue as before.